Okay, so today we're covering material from 2 chapters of our course textbook, My Educator. Still logged in, myeducator.com. Hello, go. Hello. Not chapter 7. We're on chapter data types. So chapter 6 and 7, I guess it's chapter 7. Chapter 6 and 7, the ones we're covering. So we're really looking at understanding this programming idea called an expression. We'll talk about expressions later on today. But we're going to begin with this idea of understanding what a variable is. So understanding data types, variables, and constants. I'm going to start off with the idea of a variable. Let's go to pink. I know it says here in Excel. So here I am in Excel, and let's do this. Let's draw. No. Insert. Okay, I have draw because I got some kind of tablet going on. Insert shapes. Where did they move the shapes to? I have no shapes. And I'm looking for It is not the best looking shape. Okay, forget the shape. There is one place inside the memory of a computer, inside the hardware of a computer, where I can store a value, let it sit around for some arbitrary length of time, and then bring it back. I'm working on some calculation. I get partway done with it, and I say, aha, that value, I want to set that aside for a while, and then come back to it later. There's really only one place in the hardware of the computer that I can just store that, where it's readily accessible to my program, to my process. What's the name of that part of the computer called? What's that? Clipboard. No, that's a software construct. That's part of the operating system. I'm talking about the hardware of the computer. The hardware term I'm looking for.
Memory?
RAM. Yeah, random access memory. So I've got lots of memory that I can just store a value, let it sit around for a while, and then bring it back. And that's an important thing. You've got a nice computer there. How much memory does it have in it? You know?
I don't.
How about you? No idea. How about you? No? 8 gigabytes of RAM. Okay, so that's a lot. It's probably someone that has at least 16. You know, I got 16 here. You don't have 32? 32 would be a lot. I've got 32 on my desktop computer, and I've got an extra slot for another 32 gigabyte chip. This one. You kind of need to have 64 gigabytes of RAM. But the point is that part of the computer is where I can store a value. And that's really what variables are. All a variable is it is a named location in memory where I can store a value and then get it back. So if I'm thinking about this grid, folks, this is a worksheet. But imagine with me for a moment, if you will, that this is memory inside your computer. So any one of these slots just kind of represents a place that I can store a value. So what memory? Let me zoom in a bit here. What a variable is? It's that location in memory plus the nickname for that location in memory. And if I were to think about this thing right here, it's got some memory address. We usually write memory we don't usually write memory addresses, but if we really need to write a memory address, we can either write it as a series of ones and zeros, a binary number that's saying that's the one we're talking about. After all, if you've got 16 gigabytes, you've got like 16 billion of these locations in memory where you can store stuff. Do you know how long it takes to count to 1 million? I think you're just going to count to 1 million. 1, 2, 3, 4. Any idea? 23 days. That's if you don't stop. Like you don't stop to take a breath or to pause or to drink or anything. 23 days straight through, yeah.
Do you want to do recording?
I do want to do recording. Recorder is recording. Yeah, thanks. Yeah, that little button went away, but I think we're recording. So please, if you ever get the feeling I'm not recording, please let me know. But we're gonna trust the thing that says it's recording. Pause. I'm not sure why. How long does it take to count to 1 billion? You can't do it in your lifetime, and it's largely because as you get further up, the numbers get longer to say. 492,943. 492,900. Anyway, I gotta get money. But the point is, you've got a lot of these to deal with. And so they're long. They're like 64 digits, just to say that addresses this location in memory. 64 digits in binary. If you've got a 64-bit operating system, that's what we're talking about. How many bits does it take to be able to refer to address all the locations in memory? So we very rarely represent those in binary notation. If we have to write it down, it will typically be hexadecimal notation. So we can write it like this. I'm going to highlight this particular one. Home. Put like a border around this one so you can see this is the one I'm talking about. Thick outside border. That's a thick outside border. So this has some address. It's just where it is. It's where it happens to be physically located. And I might call it BA, hexadecimal address, BA5EBA11. BA5E, which kind of looks like baseball to me, but that's a hexadecimal address. Can you imagine what it would be like if we're programming, if we wanted to refer to a location in memory, if we had to know the physical address for where it was? That'd be a nightmare. Not only would that be a problem, because it's kind of tough to deal with. In other words, if I said, I want to put a value somewhere in memory, all right, refer to the address, and you can put a value there. If I have two programs running at the same time, and they're both saying, I want that particular location in memory, that's a problem. And so when we're programming, we don't refer to a particular location in memory. We ask the operating system, give us some memory. And the operating system says, great, here's some available memory. No one's using it right now. Well, what's in it? What's in the memory already? Is there something there already? Yeah, there's something there. It's got each little location in memory has to be a 1 or a 0. There's no other choice. And 1 or 0 means something, depending on how we're looking at it. So there's already something there. The operating system gives it to us, and it says, great, it's yours. Fortunately, the Visual Basic interpreter is going to allow us to refer to that not by its address, but by its nickname. That's the name that we're going to give it. And maybe we'll just call it, let's call it tax rate. Tax, T-A-X-R-A-T. So this has, it really does have an address. It has a name. It turns out, as a programmer, I couldn't care less what the address is. That's out there somewhere. But now, I'm going to ask the operating system, give me some memory. In fact, I might say, give me 2 bytes of memory, 2 sections of memory, and make sure that no other program is allowed to modify that. It belongs to my program, and then that's safe for me to put a value there and to bring it back. So that's what a variable is. The author of our book has done a great job explaining this. Most introduction to programs. Hello.
Hello. I left a bag in here last period.
Oh, we're selling it on eBay.
There we go.
Oh, all right. Could have got something. We could have donuts, pizzas. You didn't leave a power supply, did you? A little Asus, because someone left that too. I'm having a moral dilemma because I think this actually happens to fit the computer I have at home. I'd really like to have 2 of these. A little Asus computer. All right, thanks for coming. All right. So most introduction to programming books, they talk about this in some kind of a metaphor only. They say, it's a location where you can store a value and bring it back. You have to to really understand some of the more complex things that are going to happen later in this class. You've got to get that this is a location in memory with a nickname. Here's the reason why. I can have 2 nicknames referring to the same location in memory. And if you don't get that that's what's happening here, we've got an arrow. It's kind of a small arrow. But I got insert, shapes, arrow. I've got 2 names pointing to the same location in memory. It is possible to do this. In fact, we'll do this in this class. There are really kind of important reasons why you would want to do this. And if you don't get that the name is separate from the location, in other words, it's not one construct that's a variable, one location in memory that can have a nickname, then you can really get in trouble. Okay. Question? Yeah, go ahead.
So, randomness per computer, if I were to write something in VBS as dim row as integer or something like that, send it to somebody else, would it then put that into their
would. Let's take a look at it. Let's actually look at the code in VBA to do this. Somewhere over here, I have it open here. Alt F11. Okay, close this one. Sheet 1 worksheet, insert a module. Insert module. Okay, make it a sub-procedure, variable demo. Okay, so here's how I declare a variable in VBA. I use the keyword dim. Dim is short for dimension because we are actually dimensioning memory. We are taking a certain amount of memory, a certain size of memory, and we are saying we want to give that a nickname. We are asking the operating system, allocate some memory to me. And then we'll give it a name. So we give it a name here, tax rate. And then we're going to give it a type as single. Tax rate as single. There are several different data types. I'm going to talk about them in just a minute. In fact, instead of that, let's do this as byte. So tax rate's not a very good number, not a very good name because it would be a bad one to use for the byte data type. So instead, let me just call this user choice. User's going to choose something. It's going to be a number between 1 and 10, and I'm just going to store that in a location in memory with a nickname, user choice. Right? We get it? So we've got something. We've got some location in memory out here, and we've now given it a name, user choice. And that's what's happened now when this line is processed. The first thing to realize that's a little bit weird is that this dim statement is not an executable line the way this line is. User choice. User choice equals 5. This is the line that actually executes. I could tell the interpreter pause before you execute. Put a breakpoint here. Pause before you execute this. I can't tell it to pause before it executes the dim statement because all of my variables are allocated before the procedure starts to run. So as soon as you say run this procedure, it says, okay, great. First thing, allocate all the memory we're going to need for this procedure. Next thing, start running. Okay, so this just gets us ready. It gets our memory set up. And when we say user choice equals 5, we're telling the operating system to store this value 5 at the location that I named user choice. Later on in life, when I say debug.print, user choice, then it says, oh, you're trying to print what's in user choice. It realizes user choice is a variable. It goes and finds the value that's stored at the location in memory with that name, and then it prints it out. How are we doing, folks? How many of you are going, if he says one more thing about a variable, I'm going to be sick? No one yet? Because we're going to say a lot more stuff. I don't know if we had to get the motion sickness bags out for you. So that's the basic idea. Now let's talk about the data type. So our book, the chapter 6, gives you a list of data types. It talks about all the different the restrictions and limitations on them. Let's take a little time to discuss why there's a limitation. So first of all, byte. When I allocate a byte, this variable now is going to refer to 1 byte of memory. And a byte of memory is the smallest unit of memory that we address inside of VBA. There's actually one smaller unit of memory. What's it called? It's a bit. So there's 8 bits in a byte, and we are going to work with with bytes on the smallest unit. So let's just take a look at kind of what we mean by this. Let me shrink this down a little bit. Shrink this down a little bit more. Zoom in. Let's take 8. 1, 2, 3, 4, 5, 6, 7, 8. And let's all borders. Okay. So here is one byte of memory. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So each one of these then is a bit. So let's say I'm going to store the value 5 into that location in memory. this is what a 5 looks like, stored as bits. 1, 1, and then the rest is zeros. So this is the binary representation of 5. That seems like a weird thing. Question, go ahead.
I'm sorry, when we store this on the computer, is it going to be stored as user choice or it's nicknamed 5?
Its nickname is user choice. Stand by for just a second. I'm going to center this. So yeah, this, let me go ahead and put the name right here. This is user choice. Okay, let me go ahead and kind of show kind of 2 versions of it. It turns out user choice is only going to get stored in one place. But let me show this to you so we can kind of see it. This is like the decimal representation of it. This is the binary representation of it. In memory, it actually gets stored as a series of positive and negative charges. It's magnetic memory. I don't even know how it actually is these days. But it's a series, in the hardware, it's a series of things that we can tell whether it's a 1 or a 0. And so, if we think about this in binary notation, this is my 1s column, this is my 2s column, this is my 4s. I'm going to make a formula for this. Times 2. And so, when I say user choice equals 5, as I've done right here, it stores the value 5 at that location in memory, but this is actually how it's doing it. Why am I even telling you this? The reason I'm telling you this is because what's that? You're asking yourself that very thing. I was just asking myself that very thing. Here's the reason. What's the biggest number that I can store here? I've only got 1 byte of memory to work with. So I can store more than 128 because I put a 1 here. So this is 128, 129, 130, 131, 132, 132. It's 133. Okay, so I can put 1s into all of these. And what do I get? Actually, I get the sum product of it. Oh, that's nice. So 255 is the largest. What's the smallest I can store? Yeah, if I put all these down to zeros, it would just be 0. I'm going to take this one out to a 0, and that's actually how I store 247. So the largest that I can put in here is 255. What would happen if I tried to cram something else in there? This thing is completely full. What happens if I try to put more in? First of all, can it fit? What happens if you have something that's completely full, a container that's completely full, and you put something else into it? It's going to overflow, for crying out loud. Watch this. User choice equals 5. You go for user choice. User choice equals 255. That should be okay. Thank you. User choice equals what it used to be plus 1. I'm just trying to add 1 more into that. Put a breakpoint here, and we'll run this. Okay, so far so good. That runs, that runs, that runs. I get an error. What's the error? Overflow. You tried to put too much into it, and our memory is leaking all over the inside of the computer. You've got 1s and 0s are falling. They're going to be falling out of your disk drive if you're not. You just got to be careful. It's saying what it's really saying is that if we actually try to do that, it would overflow, and so it doesn't let you do it. It's an error. So kind of the whole reason for this discussion is so you will understand that message when you get it. And you'll get that message. Overflow. You're trying to put something in the memory that doesn't fit. What's the smallest value I can record? 0. 0, 0 is no problem. How about -1? Give it a shot. It's going to be an error. What's it going to be? An underflow? We know what an underflow means. It's still an overflow. It means you're trying to put something into that location in memory that it can't take it. There's no way for it to represent it. And so that's what the error is. So we have different data types. In fact, does our book tell us the amount of memory that's taken up for those different data types? tells us the range. It'd be nice if you say how much data they take. What does?
Right there is 255
The byte, yeah. So it's 555. Yeah, I want to know somewhere it says 1 byte. 2 bytes of memory. Okay, so he is going through it. Very good. So we have some different data types, right? So here's byte. It takes 1 byte. There are other kinds of integer data types. One's called integer, and it's whole numbers plus or minus 32,767. So it takes only twice as much memory. So at first you might think, well, maybe its range is twice as big. No, because every other bit I add doubles the capacity of it. So the thing about a byte is it starts at 0. So when this thing's all loaded up with zeros, internally how it's stored, that's 0. But for a integer, which is twice as much, I'm going to put 1 zeros in there. Then every time I add another bit, all right, I double my capacity. So here's the thing. I don't know, this is really important. But when this is full of zeros, it's negative 32,767. And then it counts up as you go. So your range, you're allowed to go negative because when it's completely empty, internally it says that's a lower number. We're starting at a lower number and then counting up from there. So your 3 integer types are byte, integer, and long. Now folks, so here's the difference. Byte takes 1 byte, integer takes 2 byte, long takes 4 byte. How many of these bytes do you have? Billions! Are you really worried about 1 or 2? No. If you wanted to just say, you know what, if it's an integer, make it long, I'd be okay with it. You want to think about 1 data type. Now, okay, so let's say I've got that. I've got a byte here. That's fine. So I'll make an integer. What's going to happen if I try to put in 5.5? And then we print user choice. Yeah, it's going to round it. This is a little bit weird. This gets some people really upset. And this is like, in most respectable programming languages, you try to do something like this, and the interpreter goes, no, it's an overflow. I can't fit 5.5 into this. There's no way for me to represent the decimal portion of this. It says you can't take it. The whole mindset behind VBA is we want to try to accommodate the user, even if the user has no idea what he or she is doing. We want to avoid the error message whenever we can. And so the interpreter looks at it and goes, I can't store 5.5. The closest I can get is I can store 6. I can round it and store 6. Great, I'll store 6 and move on. So that's kind of a weird thing you've got to kind of have to realize. And that will sting you at some point in your career of programming in VBA. I expect it. Anyway. Okay, we then have some other types to be able to handle what we refer to as floating point numbers. There's 2 of them. Well, there's 2 floating point numbers, and then there's a fixed point. So let's name salary as double. So salary seems like a weird thing to actually store with a decimal, but salary now can take some number with a 0.2, and then we can print salary, no problem. You've got some limitations. The double, it stands for double precision floating point number. Why is it called a floating point number? It's like a weird word. How come the point doesn't float? I mean, doesn't float. What really happens here is that we take a part of the memory that we've allocated, and we say we're going to use part of this to keep track of where the decimal point is. We just add a little more on. We're going to take a part of this, and again, we have all these 1s and 0s. We're going to take a part of that, and we're going to say, we're just going to use that to keep track of where the decimal point is. And so if I store a number like 35.6, 35.6 or 3.56 or 0.356. These three are actually stored in memory as 356. We store here, over here in this part of the memory, we store 356. And then in this part, we say, where does the decimal point go? And so for this one, it would say it goes 1 digit from the right. This one goes 2 digits from the right. This one goes 3 digits from the right. I'm not sure that this part is as important that you understand. I don't want to. If you're looking at this going, that seems mystical to me. I don't really want to spend any more brain power on this. You're okay just kind of letting this one float by. But that's why it's called a floating point number, is because the digits that I'm trying to store are actually stored as a series of digits, and then we take some other portion of memory and say, we're going to keep track of where the decimal place goes in that series of digits. Floating point. And so the two types that we have for that are single and double. So double is a double precision floating point number. Single is a single precision floating point number. There's another one called currency. Currency is a fixed point number, which means it doesn't have to remember how many decimal places it's used, where the decimal place goes. It just always stores at 4 points of precision. So all it has to do is store the digits, and then it knows when it renders it, the decimal point goes 4 from the right. What else do we have here? Oh, date allows us to store dates. Let's take a look at the date data. Dim higher date as date. Does it seem like I'm yelling at you now? Higher date. Okay, so let's plug something into higher date. Higher date equals, let's do this. Higher date equals, and then let's put in now. I'll run that. So now is just a function that we can run that returns the current date and time from the system clock. So if I print off higher date, it'll just bring that back out. So how is it storing this date? And the answer is, it is storing this date from an initial index date. It's the number of seconds, actually I think it's the number of days since a particular beginning time. Let's do this. Let's say higher date equals 0, like day 0. Let's do 1. 1 will be a little more interesting. So it turns out that like day number 1 is December 31st, 1899. That's 1.5. Let's do 1.4. So 1.4 is December 31st, 1899 at 9:36 in the morning. What's so special about 9:36? It's 0.4. It's 4/10 of a day. That's what 9:36 is. It's 4/10 of a day. And so this is the number. So it's actually storing it as a number. Everything gets stored as a series of ones and zeros. Ultimately, everything is stored as a number. And so what VBA is doing for us is saying, oh, you want to treat this number like a date? Great, we'll store the number, but then when we show it to you, we'll show it to you as a particular date. Incidentally, I can also, if I give it, one of the great things about VBA is that it'll look at something that I'm trying to assign, and it'll try to figure it out. Remember like when we tried to store the 5.5? It said, no, I can't quite do that, but I can figure out something that's really close to that. This date type will do the same thing, I think. Let's put in here 1/1 2016 at 3:22 p.m. Okay, so I execute that line, no problem. Now this is a string, right? This is a collection of characters. Higher date is actually storing as a number. I'm giving it this string collection of characters. The interpreter looks at that and goes, oh, I can kind of figure that out as a date. And I can convert that to the number that it would take to store that date, and it will store that as a number. And so when I bring that back, it brings it back as a date. Incidentally, I can convert this to a number and find out what number that is. CDBL, convert to a double precision floating point number. That's the number that's actually getting stored internally. Okay? Yeah?
I thought that when you put something in double quotes, it tells the, VBA not to try and understand.
Oh! Back on the very first day, I told you, hit these double quotes here. It tells VBA not to try to understand it. Yeah, you caught me. So what's happening is the interpreter is not looking at this. The interpreter is not looking at this and trying to understand it. Yeah, I guess it really is. Sorry about that.
Yeah, I just want
Yeah.
It's more like an exception because you explicitly told that's a base and not a string. It's trying to force that string, which is the interpreter's not trying to interpret, into a base.
Yeah, and to do that, it has to interpret it.
That's
Yeah.
the word.
So, yeah, that's a really good point. I never really thought of it that way before, but you're right. In this case, the interpreter is trying to take this string and plugging it into here, and it's going, this is a numeric data type. I can't do that. And then it says, but before I give up, I'm going to give it one last chance. Could I figure that out? And it does. It's really, what it's really doing, watch this. Oh, boy. There's a whole set of functions that allow us to convert. Raises stuff. I see people trying to look around past my head. There's a whole set of conversions. Convert to integer, convert to double, convert to single, convert to date, called cdate. Print cdate. Convert to date. And that will convert that to a date and then print it. As a date, once it's a date, I can convert it back into a number. And then that will come as a number. I'm not sure what would happen if I tried to convert it straight to a number without telling it to be a date first. It doesn't know how to do it. So there's this whole set of functions that we can say, take a string, feed it to that function looks at it and goes, yeah, I can figure out what you mean by that, and it hands back a different data type. It hands back, instead of being a string, it hands back a date. Or it hands back, a numeric representation of it. And so all that's happening when we do something like this is the interpreter is going, let's feed that to some function to try to figure out what it could possibly mean. And then it figures it out. But good point. Okay, so that then is the date type. Currency type, date type. What else do we have? A Boolean is just true or false. Yes or no? 0 is false. What is true? Anything else. Anything else is true. So, let's try this. If true, T-R-U, if true, then B. I wonder if you can hear my B. Can't hear my B. If true, then print now. We'll talk more about the if-then statement here. But let's put in here if true really is, I think I might have dug myself into a hole that I might not be able to find a way out. 0 equals false. Let's start here. 0 equals false. That's true. False is just another name for 0. Okay, so how about this? True equals 1. That's not true. True equals 2. Not true. True by itself is -1. Why it's -1 instead of +1? I don't have a good answer for that. But if I come in here and say, if true, then print now. If true, then print now. So if I put -1, we expect that to work. If I put 0, that's false. That shouldn't actually print. But what happens if I print 1? When it's evaluating, when this if statement's evaluating it, anything that's non-zero, any numeric value that's not 0 is going to say, oh, that must be true. So it's like 0 or something else. Okay. So that's the Boolean type. Date, double, integer, long. We'll come back to object, single. String. String, then, emp name as string. Emp name equals Kevin. So far, all the data types we've talked about, when we've allocated them, they've taken a specific amount of memory. I say dim as double, it says great, 8 bytes of memory. As date, 8 bytes of memory. As integer, 2 bytes of memory. As string, this is different. Because how much memory is used for this variable depends on how much I try to put into it. And so, it takes 1 byte per character plus 4 bytes to keep track of how long it is. Because what happens when we store this in memory, what happens is we're going to allocate, it is a long set of contiguous slots in memory that get allocated for this. And so the first 4 bytes are just telling us how many bytes we're going to be using. That's the idea. And so if I've got 4 bytes, what's the biggest number I can store in 4 bytes? I'm sorry, it's not 4 bits. I just drew 4 bits. These are bits. So it's 4 bytes. So it's like 1, 2, 3, 4, 5, 6, 7, 8. It's a bunch, right? It's 4 times 8, 32. We have 32 of these bits. Do I have a count? Does it show me how many I selected? So if I've got 32 bits, what's the biggest number I can store? That's billions. And so that's how big a string can be in VBA. You could have one string that is like the whole Book of Mormon in one string. It's easy in VBA. Not even breaking a sweat. So, but the point is, for this variable, like it has to know, so the first part of it says, how long is this string of data? There's a number that tells us that, and then we start recording the characters. Incidentally, folks, how do we record the characters? Ultimately, everything's ones and zeros. Let's say these are all 0. 0, 0, 0, 0, 0, 0, 0. That's 65. That is how capital A is stored in memory. How is capital B stored in memory? 66. How could you possibly know or care about that? It's actually surprising how often it's helpful to know what that number is. You would find that by going to an Ascii table. ASCII stands for something I can't remember. American Standard Character Interchange Association for Simple, I don't know. Information Interchange. Aha! Standard, I don't know. View the image. So the point is, when your computer stores a character, here's capital A, when it stores that character, it stores it as number 65. It just remembers, when I store number 65 in that bit, in that byte, that's an A. If I store number 80, that's capital P. If I store 112, that's lowercase p. So remember, everything has to get stored at ones and zeros. How do we work with dates? It says it's a certain number, it's a number represented in ones and zeros from an index date. How do we work with letters? We use this chart to convert back and forth. All that happens behind the scenes in VB. You don't have to worry about it. That's what happens. Questions? All right. What else we have going on? Variant. There's a strange and mystical data type called variant. The variant data type will try to do whatever you want it to do. You treat it like a string, it'll behave like a string. You treat it like a number, it'll behave like a number. You treat it like some more complex data types, which we're going to talk about here in just a minute, it'll behave that way as well. In fact, when we declare a variable, dim thing as variant, string data types have 4 bytes of overhead. 4 bytes to keep track of what's going on. Variant data types have 22 bytes of overhead. Declare that variable, 22 bytes, set aside, just keep track of it, and then we'll store some more depending on what's going on. If I don't give it a type, then it assumes variant. Which brings us to our option explicit. No, it doesn't, never mind. We're allowed to do this. We can declare this variable without giving it a type. It's identical to saying as variant. We'll talk about variant a little bit more. At this point, just realize you could use it for everything. At this point, there's usually some people in the class that say, you know, we've been at this since almost an hour. Couldn't you have just said variant can do it all and moved on from the beginning? I could have, except there's a whole complex set of rules that VBA is going to undertake when you start putting values into the variant data type. It's got to say, well, do I treat this as a string or do I treat it as a number? And so that gets to be, those rules are a lot of rules to learn about how this data type is going to behave. And your life is going to be much better off if you say, you know, I know this is going to be an integer value. Let me make it type long. And then I don't have to worry about what's really in there. For example, what do you think this is going to print? Let me print 3 concatenated with 5. What will that print? Any thoughts? Yeah, 35. Not too bad. What about 3 plus 5? What do you think? 35. They're both strings. That's okay. What about a string 3 plus a numeric 5? Not an error. Oh no, VBA is going to try to figure this out. 8. What about a numeric 3 plus a string 5? What do you think? 8. Seems like there's some other interesting thing we could do here. Anyway, so the interpreter is there's a whole set of rules. When it evaluates kind of a mixed expression, it has to decide how to behave, and your variant kind of has that in spades. The big problem with variant is that you can think that you're adding a number onto it, and you're actually concatenating. So that can sting you. So if you know it's going to be a number, use a numeric data type and move on. Yep.
Do we care about this overhead, like exam?
Oh, do you care about this overhead for an exam? And the answer is no, not really. I'm going to show later in class. I'm going to show you how to create thousands of variables with one statement. Tens of thousands of variables with one statement. When you start creating tens of thousands of variables, all of a sudden you've got to worry about that overhead. That's when you got to say the difference between using a 1-byte number and an 8-byte number. That's going to make a difference in terms of your performance. But when you're declaring one variable at a time, you just can't do enough to have it make a difference when you've got 8 gigabytes of RAM to work with. Okay, so that's data types except for object. Maybe we should all stand up for a moment. Or take a break sometime. Stand up, touch your, rub your shoulders. Rub the shoulders of the person next. Don't get too fresh. The whole point here is that we've been talking about these variables, and it's been kind of like, oh, isn't this class over yet? No, it's not over. But this next thing that we're about to do, I need your whole mind back with us. In fact, for those of you who are going variables, I got it already. You don't have this next part. Object variable is totally different. All right, thanks for the break, little break. Come on, come back, student. That kind of break. Okay. What's an object? Someone tell me what an object. We talked about it. A thing. That's another thing. Anything that I can manipulate through code, that's an object. Well, that's kind of a sloppy definition, but we're okay with it. So, if I look at, here I got this worksheet open. Here's a worksheet. You go to a brand new worksheet. This thing, and let's look at this particular one. B3, cell number B3. That's an object. There is an object sitting in memory that's got all this information about B3. At least there will be as soon as we put a value in it, for sure. Okay, so now for sure there's an object in memory. Keeping track of B3. Let me put Fred. Wait, no, let's put Nephi in there. At some point you're going to have to answer a question about whether I appropriately brought in gospel topics. Do my best here, folks. Okay, so here in B3, we've got some value, and I can ask a question about that range. Range number B3 dot value. There it is, Nephi. Okay, so that's sitting out there in memory. There are some times when it's really nice for me to be able to create a reference to that variable or to that object as a variable. Sub object variable demo. Dim my range, my RNG as range, as object. Set my RNG equal to range B3. Not to range B3 dot value, but to range B3. So this is the reference to an object. I am now going to bind this object variable onto this object. Once I've done that, anything that I could say with that reference to that object, I can now say by its variable name. My range dot value. With normal old mortal objects, I can never say x dot anything. There are no properties. Objects don't have, variables don't have properties. The truth is, this variable doesn't have a property either, but what happens is this gets resolved to the object it refers to, and then I'm referring to the properties of the object. All the variable is, it's enough memory to hold the address, some other location in memory, the address of that object. Let's take a look at this. First of all, let's see that this is going to print Nephi when I run. Let's do this. You might think, well, why do this? Why not just refer to it as range B3? It's not that tough. Here's the reason. I might say, I want to do something with whatever cell the user has active. And then I might need to activate some other cell as a part of my process. Let's just do this. Let's just say active cell, offset, 1, 0, not select. So here's what happens. Whatever the active cell is, right now it's B3, whatever the active cell is, gets bound on to that variable. We then change what the active cell is, and now we're going to print the value of that object variable. What's it going to print? It's either going to print Nephi, or it's going to print Lemuel. By the time this line executes, here, which is the active cell? Yeah, Lemuel's going to be the active cell, but I'm not printing the active cell, I'm printing my range. So the question is my range now just another way to say active cell, or does this variable get bound on to whichever object is the active cell? In other words, right now, it's B3. We bind onto B3, and even though we then change the active cell, this is still looking at B3. It's one of those two things. If only there was a way for us to find, oh yeah, we can run it. You can see that it's selected Nephi, but my range is still bound, selected Lemuel, selected B4, but my range is still bound onto B3. In memory, what's happening here is I'm creating a variable here. Let's do it over here on sheet 1. I'm creating a variable that's just called my range. And here, when I say set my range equal to active cell, what really gets put in there is the memory address of that object. That object is loaded somewhere in the memory. What are we going to put there? We're just storing the location where that object is. We're storing the address of that object. Because this is an object variable, when I refer to that variable, it actually says, oh, you're not talking about the actual location here in memory. You're talking about the object that that refers to. And so it makes this extra hop for us automatically. How many of you are going, that's really weird? Yeah, this is kind of a complex thing. But here's the thing. That's what an object variable is. But I can actually do a little more specific. I can not just say object, I can say here range. If I give it a particular kind of object, like a range, then it does exactly the same thing. There's only two differences. The difference is, if I now try to connect this onto like a worksheet object, it's going to fail because it's only allowed to bind onto range objects. But the really nice thing is that now in my code, if I say my range dot, my RNG dot, it brings up the IntelliSense help. It knows that this has to be connected onto a range object. And so it tells me what I can actually, what are my options with this variable. Ooh. So that's the idea behind an object variable. Questions? You probably have some questions about this. We'll get familiar with it. Go ahead.
How do you initially, if you were to run this procedure again, would the active cell become C18?
If I was to run this again, so right now C18 is the active cell. So if I run this now, my range variable is going to bind onto this object. And then it's going to activate, because it activates the next one, it'll activate the next one. Yeah, so there's nothing about this that says it's always going to bind on to Nephi. It's going to bind, that's the whole point. It's going to bind on to whichever cell is active. This is a really handy thing to do. Tell the user, activate the cell you want to start working on, and then run, and you'll say, okay, I'm going to keep track of which one is active, and then we're going to be moving the active cell all over the place. I want to know which one was active initially, because that's going to have some meaning. Go ahead.
After running the code, does my range still store that address, or does it clear it after the code already?
Oh, good question. So the question is, so how long does my range live? How long does this variable live? It turns out every variable that we declare inside the subprocedure is allocated. Memory is allocated for that name at the point when the subprocedure starts running, and when I hit the end sub, gone. It releases that memory back into the wild. Gives it back to the operating system and says, thank you for letting me use this memory. You can have it back. Next time we run this subprocedure, we're going to ask, hey, I need some more memory. Am I going to get the same memory? That would be really unusual if I got exactly the same locations in memory the second time I ran it. And so it'll just be, the operating system goes, yeah, we got some memory available, here's some memory you can use. Okay, folks, I do want to take a look at expressions. That's chapter 7. The whole idea, didn't get to constants. I skipped by constants. Let me quickly cover constants. A constant is exactly like a variable, except you can't change its value once it gets its value. The way you do it is like this. Const pi as double, and then we give it a value right here. We actually give it a value on its declaration. And so now it's the same thing. It's a name for location in memory. It has a value. I refer to it the same way. The only difference is I can't change it once it's established. Try to say pi equals something else. And run this. Whoops. Pi. All right. Assignment to constant not permitted. You're not allowed to change that value. You set it once, and then you're done. Okay. the idea of an expression? An expression is anything that we can look at and evaluate it down to a single value. So a string is an expression. It's a single value. 3.5 times 5 is a single value. I can get that down to a single value. 3.5 greater than 9. Is that an expression? Yeah, that's true. I can look at that. 3.5 times 5 is greater than 9. Yeah, it's 17 point something. So yeah, that's 3.5 equals 9. Is that an expression? What do you think? Is it an expression?
Yes.
It is. It's an expression. It happens to be false. So expressions can be string expressions. They can be numeric expressions. They can be Boolean expressions. Any data type, there can be an expression that evaluates to that type. So, a string, you can have here Nephi concatenated with Lehyson. And this is a string expression. It's more complex, right? It's got to do a little work to get down there, but then that's that expression. And so we use expressions. You want to think, anywhere that I can put a single value, I could put an expression that evaluates to a single value. Here's an expression you might not expect. So we saw a little bit with message box, MSG message box. Help. I'm going to run that, and it, puts the message box up and says help. That's great. But what we're going to find out is that it is also an expression. It's an expression because it will return a value. Let's see what it returns. I'm going to execute this line. It comes up. I'm going to click OK, and it returns 1, which seems weird. Okay, let's do this. Let's give it some other buttons to choose from. Like yes, no, cancel. Yes, no. Now I got a yes and a no button. Yes returns 6. No returns 7. And so the point is, now anywhere that I could put a 6 or a 7, I can put this expression. So if I wanted to say, well, that's what I've done here. Let's see. Let's do this. Let's say active cell dot value equals. Before it can know what this expression evaluates to, it actually has to put up the message box and allow the user to do whatever the user is going to do there. If I run that and I click no, then it's going to say, this evaluated to 7, and then it figures out to do the rest of this and says, okay, we'll just go ahead and run that along. So expressions can be very complex. Let me show one more kind of expression. True and false. What is that? True and false. What's the value of that expression?
0.
Sort of. So it's false. That's a false statement, right? True and true is what?
True.
So true and 6 greater than 7. True or false? False. Or 5 less than 77. Now the whole point here is that anywhere I can use a single value, I can put an expression because the interpreter can look at that expression and it's going to evaluate that down to a single value, plug it in where the expression was, and move on. And they can get fairly complex. All right, constants, variables, expressions, comparison operators, logical operators. So this is going to be a lot more for reference. You want to find out what can you do with math. You've got plus, you've got minus, divide, integer division, modulus, exponentiation. What can you do with concatenate strings together? Last thing for the day is another thing on the options. Substring. String B. Okay. Debug.print. What do you think? Fred equals Fred. It's going to be true or false? Which one do you think is going to print? Only thing that we got capitalization. It's false. By default, strings are case sensitive. Unless option compare text.
Why did it automatically define it as a string?
It's doing this as strings because of your string literals. In double quotes, it goes up. Those are strings. I know. Figure that out.
Yeah.
Now that I put option compare text up here and I run this, this evaluates to true. This option then tells the interpreter how to interpret this stuff. What should it do? This option does the same thing. Should we allow ourselves to use variables without declaring them? We say option explicit. The answer is no. You've got to declare it before you can use it. Option compare text says, hey, I'm not going to care about capitalization when I compare strings. And so you can say option compare text, and that applies only to this module. Anything in this module now will have case insensitive string comparison. Yeah.
Is option explicit the default?
Option explicit is the default when you have required variable declaration checked. Tools, options. When this is checked.
Is that why it always pops up when you open a new module?
If this is checked, it'll pop up when you open one. I don't think you can do the text one in here. I've never seen it before. Okay, homework due at 11:59. Are you going to project due at 11:59? Thanks for coming. I will see you on Wednesday.